I presented a paper at SMTAI 2016 on reducing voids in bottom-terminated components. A little background on SMTA. SMTA, or Surface Mount Technology Association, was started in 1984 as a nonprofit organization to foster education in the then new field of surface mount electronic assembly. Since then, it has expanded to include all of electronic assembly. For many of us, it is our favorite industry or organization, as it is very collegial and feels almost like a family. SMTA has also stayed true to its educational mission. SMTAI is their international conference and exhibition. It is the one conference I always try to attend. My paper is Minimizing Voiding in SMT Assembly of Bottom-Terminated Components, or BTCs. Indian Corporation's Chris Nash performed all of the experiments, and I analyzed the data and took the lead in writing the paper. I think the paper is significant in that Chris performed experiments on many of the important factors that would affect voiding. We determined some interesting and one profoundly significant conclusion. Chris used two reflow thermal profiles. Profile 1 was a ramp to peak profile with a maximum temperature of approximately 240 degrees C, whereas Profile 2 had a slight soak and a peak of 254 degrees C, and also had a slightly higher time above liquidus of 77 seconds versus 70 seconds. We expected Profile 2, which is hotter, to reduce voiding some, but we're surprised that the reduction was from 22% to a little less than 8%, a reduction of more than 14%, which we think is quite impressive. Our theory is that the hotter profile is more successful at driving out the flux volatiles. The second conclusion was related to stencil thickness. Chris performed experiments with 4 and 5 mil thick stencils. The 5 mil stencils reduced voiding by only 4% as compared to the 4 mil stencils, but the result was statistically significant. We think that the hotter standoff of the 5 mil stencils allows flux volatiles to escape more easily. Thirdly, in testing Type 4, Type 4.5, and Type 5 paste, there was not statistical difference in void formation among them at 11 to 14% or so. However, Type 3 paste was much more than 15% higher voiding at 30%. And the most significant conclusion was that we found that the solder paste alone can have a profound effect. Under the same experimental conditions, we were able to reduce voiding from 45% to less than 10% by selecting a solder paste designed to reduce voiding. This is really important to those struggling with voiding under bottom-terminated components. By simply switching to a superior solder paste, one has a very high chance of solving a voiding problem. The top X-ray images show poor area voiding percentages greater than 30%, while the bottom photos show voiding of less than 10%. For more information, email me at rlasky@indium.com or visit the website indium.com to read my paper.